I'm here today at the Health Physics Society's annual meeting. Health Physics is radiation protection, radiological safety. It's the professionals that do that. And it's also being held at the same time as the International Radiation Protection Association. So people from around the world that do radiation protection and radiological safety. And I just got done doing a session on naturally occurring radioactive material, or NORM. And the last paper in that session was really interesting. Now, to define what NORM is, naturally occurring radioactive material, the International Atomic Energy Agency defines that as being any soil or mineral material like that that has more than 1 becquerel per gram of radioactivity concentration. Now, typical soil has around a quarter of that. So basically all soil is radioactive, naturally radioactive. Uranium, it's about 3 parts per million in any random sample. And plus you have all their decay products, plus you have potassium, which is also naturally radioactive. And the reason that this particular paper was interesting, it was a comparison of the public health effects, or not health effects, more specifically public dose from different energy forms due to naturally occurring radioactive material. When you compare, say, the mining and milling and the manufacturing associated with nuclear energy to simply wind and solar. And why that was interesting is for wind and solar, you actually have to have a lot of rare earth minerals, specifically the element neodymium. And when you have neodymium, you're going to have a lot of the NORM in that dirt. And what was interesting about this publication is that the public dose from wind and solar is higher than what you have with nuclear energy. It was, in US units, it was higher than around 100 millirem per year from wind and solar, whereas with nuclear it's less than that. By law, it has to be less than that. And I know that there are a lot of people in my industry that think that we shouldn't regulate nuclear so strictly. We shouldn't have such extreme, hyper-conservative limits. I've actually never adopted that perspective. I just think everybody else needs to be as safe as nuclear, so that if at nuclear we spend $400 million to prevent a death, that everybody else needs to as well. So that, you know, even the medical industry, they might only spend, say, $40,000 per person to prevent a death. But if everybody had the same standards as nuclear, in my opinion, would be the cheapest, the fastest, the most economical and safe and sustainable energy form that's out there. Again, just my opinion. But I thought that that was interesting because when it comes to naturally occurring radioactive material, there is that limit. And another thing that's interesting about that is that the Fukushima water, right? If you remember, the definition for NORM is 1 becquerel per gram. The Fukushima water is going to be 1.5. So, I mean, tritium is naturally occurring, but the radioactivity in that water is 1.5 becquerels per gram. So it's just barely above that NORM limit. And most states don't even regulate NORM. It's because the chemical hazard generally is far outweighs the radiotoxicity. And so just some interesting things that came from the meeting. I'll keep you updated if I see anything else, any other really cool presentations here. But thanks for watching. I hope you learned something and you have a good day. Bye.